Okay, so what we are doing, we are solving this example. It is a curvilinear motion and we are solving using rectangular component method or Cartesian coordinate system or XY coordinate system. So XY is given, how to find the combined velocity. We will take the derivative of X component, that will be our velocity in X direction. Whatever Y is given, we'll take the derivative, we will get the V component of the acceleration, V component of the velocity. The question is asking velocity after 5 seconds. So what is V after 5 seconds? Vx, say Vx after 5 seconds. This portion is 0.9 t square. So okay, write it down here. 0.95 square. So 5 square equals 25 times 9. That means 225. I might be. What is the unit? Meter per second or feet per second? You should see it from the example. X and Y are in meter, T is in second. Okay, that means it is meter per second. So Bx is done. What is By? After 5 seconds. So this is 0.6 t square. If we insert t 5 seconds, I can see 5 seconds 25 times 6. Oh, last time did I do the right calculation? 25 times 22.5. So here 0.65 square, that means 15, yes, 15 meter per second. So what we did, we considered X and Y as a separate motion. X, find Vx, for Y, find Vy, then combine together. Then if I combine square plus, bring it here, whatever you will get, that is the velocity after 5 seconds. So I believe that you understood this. There is nothing rocket science here, clear cut. Now if I want to find the acceleration, say Ax, how to find Ax? D by dx of Vx. What is Vx? You can find, no, Vx, this is your Vx. So Vx was 0.9 t square. That means 0.9. We do not disturb the coefficient. Bring the power down and decrease the power by 1. I had 2, now I had only 1, or 1.8 t. What is your Ax after 5 seconds? Simple, 9, I think. I am not using calculator. If I make a mistake, please excuse me. So what is Ay? D by dy Vy. D by dy. What is Vy? Vy is 0.6 t square. That means keep 0.6 and bring that 2 down, and t is 1. Now I can tell you that now you are not scared about calculus, and maybe you did not realize, but you are seeing that you are using calculus last 3-4 weeks and you are not scared. It's not really difficult. I don't know, maybe your senior colleague or senior classmates, they told calculus is difficult, so you are scared, but actually it's very simple. Okay, so what is Ay? Ay after 5 seconds is 1.25. That means 6. Oh, X, so meter per second square. It's not meter per second. Meter per second square. What is your combined A? So insert it here, insert it here. Whatever you will get, that is the answer in meter per second square. So I believe that you understood this, how to deal with planar curvilinear motion using rectangular component system or Cartesian coordinate system or XY coordinate system. What is the rule? Just assume the motion as a two independent motion. So motion in x, solve it first. Motion in y, solve it first. Then combine it by using this. I do not know what do you call it. Is a parallelogram rule or Pythagoras rule. Whatever you call, both are right. So if we can derive this equation using parallelogram rule or Pythagoras equation for right angle triangle. Why right angle triangle? Because it's x and y. They are, say if this is x, this is y, their angle is 90 degree. You are simply determining the this diagonal. So this is actually this the diagonal. This is a y, this is a x. Okay, so hopefully you understood. I will solve one more example in your book, but before solving, let us see whether I did right or no. Okay, see first, see that they did the Vx independently, Vy independently, and then they found the value after 5 seconds. Inside 5 seconds, you got this number, and then they took the Pythagoras or parallelogram rule. Same thing they did for Ax, Ay independently, and after that they found the value, and then they found the combined acceleration. So next, same thing, yes, similar other problem. Yeah, this example. So what is this example? The end. Yeah, this example is little lengthy and little advanced. So should I do it? Oh, I think when I was thinking in my last portion, did I make a mistake? Yeah, see, I made a mistake here. The mistake is all about, it's not mistake when I was talking. You can see I did the d over dx. I should do d by dt. The reason is it is a function of time. Function of time. So everywhere I did x, see, here, here, it should be time, time, time. Yeah, so this mistake is not a big mistake, it is just that like um, variable. My variable is with respect to time, so we should use time. The reason I made this mistake, I was thinking this is x and this is t. Yes, but actually this is t. So we should do the derivation with respect to time, because change in displacement over time is velocity. So over time, not change in displacement over displacement. No, 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 is time. Okay, so we will go there. When I saw this time here, then I realized, oh no, I did some mistake. Okay, so what is happening here? This p and it is like sliding this way, and the path is y equals 20x square, and the coordinate of p and the value of this p is varying with time as this way. That means when this bar is moving this way, oh no, I should not move actually entire bar. So this bar, when this is moving that way, the moving rate for y is by this equation. So it has two equation. So now what we will do? We will do both separately. Vx dx by dt, vy dy by dt. We know that. Even what is the question? Velocity or acceleration? Both. Both velocity and acceleration. That means we should do both. So you can see this is my velocity, and then we will go for acceleration, or maybe they did not do acceleration first. Oh no, they did not. They do velocity at the beginning. Now, if I go here, only the equation here. Now, what is Vx? dx by dt. But do you know any x? That is the question. No. If you see, if you go below the problem, there's nothing given x equals something. Nothing given. But there is given x is here. So x is actually, we need to rearrange this equation. Rearrange this equation. How? X equals y square over 20. That is x. Okay, so if I open this, even same thing here. Okay, so if I make it smaller, so what I will do, you know that I need to find my x, I need to find my y. So y is given, is directly given, y is 20, x, oh no, 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 y square is 20x, and that means y is square root 20 and x is half. But x is not given. But how I can find x? How? X is y, uh, yes, x is no, 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 no. I made mistake maybe here. X is y square by 20. So it is actually given. We need to rearrange it. Now, when you will do the derivative of x, vx is d by dt. Last time I made this mixes. D by dt. Velocity is displacement over time. So I made that mistake. So I need to insert this. But if I insert it here, you can see the variable is y. But I'm doing the differentiation about x. So I need to convert it. How? Another equation is given for y. Y is this. So what I will do, d by dt, my y square is 40 square 60 square divided by 20. Now I need to simplify it and then do the differentiation. Same thing for y. What is my vy? Vy is d by dt square root 20, and oh here x, maybe it's not clear, square root 20 and x is power. Now again, yes, again you said there is x here, but my variable here is time. That means I need to convert this x to time. So actually, I do not need to do it. I can go directly. So d by dt. It is important to note that my variable is time. My function must be with respect to time. So I do not need to. I can put directly the y. Directly the y. How? I know the y. Y is 40 square plus 60. Yeah, maybe I told at the beginning this problem is little advanced. The reason is here x, y are not given directly. I need to make the equation. Here just they gave me the equation of path and how my y coordinate of path is varying with time. So I need to use these two equation to get my desired equation. Now you can see once I converted everything into time, the time. Now it is very simple, but B is no, sorry, not very simple. I need to make it simple because it is still confusing. So I need to do some mathematics only. I need to put it in the linear. Okay. So if I do say this portion is simple, I will not disturb 4, bring the power back, and t power will be 1. Same thing, uh, keep the constant, bring here nothing means power is 1, and then 1 minus 1 is 0. So simply this portion is 1. So simply it is 80 plus 6. So y component is very easy. X component, you can see I need to simplify here. How to simplify? Okay, let us do simplify here. 40 square 60 times 40 square 60. Square means I can do right twice. Then do the multiplication. 4 times 4 is 16 t to the power 4. Then 4 times 6 is 24 t to the power cube. and 6 times 4 is 24 t to the power cube. 6 times 6 is 36 t square. It is just mathematics. I am multiplying two quantity. So 16 to the power 4. Then this component will be 48 t to the power cube. Then 36 t square divided by 20. You can see 20 here. Okay. So I will not disturb 20 now. Keep 20 here. Now, if I do the derivative of this portion, derivative of this portion with time, what I will get? 16 t to the power, oh, I'll bring the power down, t to the power cube, 48 t to the power square, 36 times 2, 36 times 2 t. So that is my derivative. It will come actually here. Done. So Vx done, Vy done. Insert the value, find it. So that is the concept. This problem is little longer, but not difficult. It's just systematic. Okay, let me see my handout because I'm like suspecting something. Is this problem so big? Should I give it or no? Or that I try to make all the example simple. Oh no, same thing. First I did it, I simplified and made it a simple equation, and I did the differentiation of that equation and then inserted the value. Same thing for y. Yes, this example is bigger but not difficult. Okay, so any question?
Sorry, I just have one question. Is this for a test test?
Oh, I could not hear. I don't know why the sound is very less. Yeah, Dima, one more time, please.
Yeah, the one that you just explained, sir. Is this for MCQ test coming up?
Oh, now this kind of question, I do not think that they will put in the MCQ. So this kind of question they will maybe in your class exam is okay, but MCQ, no. In MCQ, per question in AP exam you will get 2.7 minute. So never in that question you will get a bigger question. In class we learn bigger problem, but in AP exam no, never. Welcome. Okay, so if I go to my share screen. Yeah, for others, what Dima asks that if this question will be in the MCQ, no, never. It will take at least 20-30 minutes. But again, concept is the same thing, just many mathematical operation, nothing else. Okay, so how to find acceleration then? We know our, if I go here, we know our expression for velocity, If we do one more derivative, we'll get the acceleration. Then we can find it. So next part I'm not doing it because you'll be bored. It is in here. You can see what I did next. Acceleration, differentiation of my initial function, the simplified function, and did it, inserted the value, I got x. Similarly for ay, I did one more differentiation, inserted t equal t second, 6 second, I got 8. Okay. Then I combine these two. So you can see here, okay, oh, I need to. So what you can see here that there is no new knowledge, just the same knowledge, it's the application. So I will